Now to make sure my machine comes back on. All right, good, it does. That's a plus. All right. Let me change this. Okay, so that actually looks like it's set up right. Quick question, how much time do I have? 2 hours? What? 400 minutes, okay. Let's see, that's 6 hours, got it, okay. I really came up here thinking I had like a full hour. So I'm going to try, because I absolutely hate to just throw a ton of stuff at anybody because it's just too much, right, to try to absorb. And I don't want to cover like 24 things scattershot. I want to cover a couple or three things really well, right? So I'm going to try to maybe skinny down the explanatory stuff. If you do have any questions or anything afterward, please do see me. I'm happy to talk at length about this stuff, as you might imagine. I did bring up my coffee and my water, so we should be okay, as long as I keep the water far enough from my laptop. But welcome to this afternoon session on drinking from the stream, or how to use messaging platforms for scalability and performance. My name is Mark Heckler, and these are the best ways to reach me. Twitter really is the best way, but you know, email works too. So distributed systems are easy, right? They're so easy, I'm surprised anyone even came this afternoon. No. We know the problem with distributed systems, or problems. They're actually rather complex, more so than we would prefer, right? So who am I, and what makes me sort of semi-pseudo almost qualified to talk about this? Oh, good, we have a clock, so I can like race the clock. I have authored several blogs and blog posts. I've co-authored a couple of books. I've contributed content and code to several other books, a few of which even actually recognize my contributions. That's always nice, right? The others, well, don't read those. Anyway, I do have another book that I'm working on to be released, hopefully, pending August 1st next year, which I'll get to in a moment, but that's neither here nor there. I am an architect and developer by trade, and as you might surmise from the next point, where most of my expertise has been it's been in the Java ecosystem, the JVM ecosystem. I have done some Groovy, I've done a lot of Java, and I've done some Kotlin. Any Kotlin fans? Yeah, okay, loud and proud. All right, good. Yeah, and there's a special surprise for you at the end too, and the rest of you who might be curious. I am a professional problem solver. That's not my official title, it's just what I do, right? That's what you do, that's why we're here. Officially, I am a Spring developer and advocate. I commit code, I talk about code, I do the two things that I love best after my wife. This is recorded, right? Right? Okay, good. So that's kind of my job, and I love my job. I am also the sole creator and curator of Spring Noticias en Español. So if you're a Spanish speaker as well, I collect and amplify your voice. I collect the resources and share them with the broader community. If not, that's fine too, right? Okay, so this is my new book, sort of. This is actually just a parody book cover. I do have a contract with O'Reilly to produce this book, but not with this cover, hopefully. Gosh, I hope they don't stick me with that cover. The title is going to be Spring Boot Up and Running. It's supposed to be an intro, but also a kind of a guide, guide through Spring Boot to some deeper topics as well. I was looking for a running monkey. That's me. I'm the running monkey. And this is the closest I could find. So again, I hope this isn't what they choose, but yeah, so what if it is, I guess. But if you're curious about the book, follow me on Twitter. That's where I make all the announcements and stuff. And if you're not following me on Twitter already, why? Why? MK Heck, by the way. All right. So, really quickly, and actually a little quicker than I would like, some of the things that I want to talk about today, and before we launch into the code, because I think it's important to have some degree of context, right? When I first gave this talk, I just launched into the code, and I felt good, right? I'm a coder, and people felt okay with it, but there were several questions afterward that, like, okay, when you did this, why? And when you, how did you set this up? And I felt like some context was missing, so context is key, right? So here's some context. Coming from the world of monoliths, I guess, why would you use messaging platforms? Where do they fit into a distributed architecture? Well, let's step back from that a bit and find out why we would need a distributed architecture to begin with. Most of us in most environments have some number of monoliths, right? And monoliths are okay. Monoliths provide a lot of functionality for a lot of different enterprises globally. But the problem with monoliths, or a problem with monoliths, is they include a lot of functionality in one bundle. So the problem with that is that within any collection of functionalities, you'll have some functionalities that will be used a lot, right? And some that are hardly used at all. So I think of something like a retail site. If you're a good retail site, you have a selection of products that have great product market fit with your market, right? So you have good quality products, you sell at a good price, you have a good bead on your market, so you'll sell a lot, and you'll take in a few returns, right? So your sales module will be used a lot, and it'll need to scale to crazy extents and then maybe back in. But your returns module won't be used much at all. You need to have it there. It needs to be quality and work well and be seamless and frictionless for your users, but it doesn't get used much, right, in comparison. But when you scale that monolith, if everything is bundled in one monolith, you scale everything together. So the thing that you need a lot more of, you're dragging along this thing that you don't need any more of, just by default. So you have 2 instances, or 3, or 10, or 20 instances of everything. So it's a lot of dead weight in that context, right? So we start teasing those functionalities, those heavily scaled functionalities out into microservices, which also, by the way, increases your development and deployment velocity because you're not having to go through and verify functionality and test and bundle everything up in one unit every time you want to scale this particular functionality. When we start doing that, sorry, we got some good feedback here. When we start doing that, we typically lean on HTTP-based APIs to begin with, right? REST APIs, typically. And when we do that, we start getting some of those benefits of teasing out that very volatile or the functionality that really needs to scale quite dramatically. But we start realizing something else when we do that, because we start realizing that a piece of functionality isn't typically provided by a microservice. It's provided by a small group of microservices. So service A may be our interaction, our interface with the user, but service A calls service B, and service C calls service D, E, and F. And then all of them work together to provide that functionality to the user. That's okay, except then we realize that we haven't fully decoupled everything, right? Because service A, when we need to scale that, we're gonna probably scale service B rather linearly with that. So if we have 100 requests coming out from service A to service B, and we say, wow, we're pegged. Okay, let's say a few more. Let's say 500. And we need to scale to a second instance of service A, we're probably going to scale a second instance of service B. So we're coupled, right? We're coupled locationally, and we're coupled temporally because they both need to be online at the same time to make that happen. Where do we go from there? Well, I like to call messaging platforms next level scaling. Messaging platforms offer really unequal scalability and flexibility. You have temporal decoupling because you have things like pipeline retention and guarantees, delivery guarantees. So if you have a producer of a value, of a message, and it pushes that value into a pipeline to be consumed by another service, that consuming service doesn't even need to be online at the time that message is produced and dropped into the queue. Let me back up. I try to avoid terms like topics and exchanges and queues and things like that that tie to a particular messaging platform. I try to keep it at a higher level abstraction pipelines. So whatever you're using, whether it's Kafka, Rabbit, or something else, that's fine, just think pipeline, right? So when you have a producer that produces a message and pushes it into a pipeline, by the way, whoever's phone rings next has to come and finish my presentation. I should have probably warned you. That's why I didn't pick on whoever. Because they're like, oh no, oh dear. So that allows you to temporally decouple. Let me move that down just a skosh here. It allows you to temporally decouple. So when service A drops a message into the pipeline, service B may not be online, any instances. But when they come online, they don't necessarily need to know or care where those messages came from. They just said, oh, look, I have a message, and it processes it, right? So it allows you to temporally as well as locationally decouple your multiple services. Let's see, practically on routing, unlimited routing variations. So you have a lot of flexibility in terms of routing. You don't have to stay with a one-to-N or N-to-one. When you have messaging platforms that are built around the concept of routing, you can get crazy with your number of permutations you can have for routing. You can implement proven patterns of routing, message routing and processing. You can come up with new ones, right? Because it gives you that kind of flexibility and building blocks that you can do that kind of thing with. So next level, let's see. Examples of leading messaging platforms, there are too many to talk about. I like to kind of bubble it up to the top few. I consider to be the first among peers, things like RabbitMQ and Kafka, which have been around a long time, are super well proven, well established, very performant, very flexible. And then you have all the major cloud providers that have one or more, typically more options in terms of messaging platforms. I like to roll those up to the top, what I consider to be the top one from each of the big three, but obviously there are others as well. So things like Amazon Kinesis or Google's Cloud Pub Sub or Microsoft's Event Hubs. Those, by the way, none of those are open source. I don't know if that matters to you or not, but it's something to factor into your decision making. I like to consider among those peers, the first of those among those peers as RabbitMQ and Kafka because one, they're open source. Two, they can be run anywhere. You can run them on-prem. You can run them in any of the cloud providers. You can also run them in various different third-party hosting providers. You have many more options at your disposal. So again, I don't know if that particular checkbox is important to you, but in many cases it is. As you might imagine, one size doesn't fit all, right? So maybe your company is standardized on RabbitMQ because of its unparalleled routing capabilities. And then you partner with a company who's standardized on Kafka. Now what? Well, that can be interesting, right? Even when we standardize on one particular platform, we partner with companies. We get bought by companies, or our company acquires another company. We have customers who are using something else, and we want to expose an API. So it would be really nice, wouldn't it, if we had some way to abstract above that, so we didn't necessarily care about the underlying configuration, unless we had a specific need, right? Generally speaking, as developers, we care about what? Pushing messages and pulling messages, processing messages. We don't necessarily care about configuration of replication. I mean, it's important, right? And we may do that once, but once that's in place, it's not like we have to think about that on a daily basis to deliver business value. Business value comes first. Spring Cloud Stream fills that bill because Spring Cloud Stream works with all your major messaging platforms, and it does this using binders. So you have a particular messaging platform, let's say Rabbit. There's a RabbitMQ binder that allows Spring Cloud Stream to interact with it. Same thing with Kafka, same thing with Kinesis, et cetera. So that allows you to focus on the real business value part of the whole process and not necessarily the details in the weeds. You still can get to all the configuration settings and tweaks, but in most cases, you don't have to. You can focus on the higher levels. Okay, so let's see. I'm trying to make sure I don't miss anything before I launch into the fun part, right? Spring Cloud Stream is largely based on Spring Boot and Spring Integration. Spring Integration has very consistent but versatile hooks. Spring Cloud Stream kind of focuses those specifically to messaging platforms. Spring Boot brings what? It brings three big things and many other little benefits, but things like auto configuration, simplified dependency management, easier deployments, right? Consistent deployments. And Spring Cloud Stream gives you all of that, as well as an evolving API, which is meant to, in the spirit of Boot, give you convention over configuration, easier and less leaky abstraction-y implementation, so you can, again, get down to business fast and do what you need to do. And I'll cover some of those as we go, right? All right, let's see, kind of covered most of that. Yeah, I also mentioned that you can get to under all the controls under the hood should you need to. But on top of that, no pun intended, maybe a little pun intended, let's say the new CTO reads an article and insists that now everything moves to a different messaging platform. You can switch messaging platforms with just a rebuild of your project using a different binder. Or, even better, if you've planned ahead, it's just a simple restart, right? You just tweak an environment variable and you're off and running. So it's super, super flexible. Hopefully none of us live in the world that we have to maintain that degree of flexibility across everything, but it's nice to know it's there when you need it, right? Okay, so again, a little bit of context. Some of the things that I want to discuss and show in code, we're going to take Spring Cloud Stream and plug it in with a messaging platform, your messaging platform of choice. And I'd like to do this to kind of show off some of the power of what you can do with it. There are three built-in interfaces defined in Spring Cloud Stream. One is your source. The source is the thing that produces values. That's it. Simple. One is your sink. The sink is the thing that consumes those values. End of line, message processed, done, right? In between, you may have one or more processors, or zero or more, I should say, because you technically can just have a source and a sink. But you can plug in any number of processors in between, and a processor is a transformer. it takes a value of some kind, manipulates it, and passes it on to its downstream processors and or sinks, right? So you can create your own interface, right? You can create your own version that has multiple subscribable channels, multiple message channels, and you can fan out and create your own patterns, right, with your own interfaces. But in 80 to 90% of the use cases, just like most things Spring, it's kind of opinionated to focus toward that 80 to 90% of the use cases. Any combination of these will cover most of the particular needs out there. So it's pretty nice, just right out of the box. Now, you also have some pretty nice scalability, and I'll give you, assuming we have time, maybe not, but we'll talk about it afterward if not. Scalability is dead simple as well. You also have the ability to flip to a different underlying messaging platform with not a lot of work. Any managers here? Any leaders? Okay, nobody admitted it, that's fine. If not, if you are a manager and you're just a little nervous about like raising your hand, I get that. You might want to step out when we get to this part. I will say it's pretty simple to make the underlying switch. I don't necessarily want to get anyone into trouble. Don't ever lie to your boss. But if they ask you how much effort it's going to take to rip and replace the underlying messaging platform, know that you have help, right? And then, of course, if you need to interact with multiple different underlying messaging platforms, that's pretty easy as well, and I'll show you that as we go. Now, I did show this, the source processor and sink, and this, truth be told, is kind of the legacy API for Spring Cloud Stream. And a lot of people have used this to a lot of great success over the years. That's fine, it still works. But this is about the evolution of Spring Cloud Stream. Today, I kind of want to show you where it's going. And if you look at this, the source, the processor, and the sink, this lines up really well with three concepts in Java itself, which is that of a supplier, a function, and a consumer. A supplier supplies values of some kind, right? A consumer consumes them. And then in between, you have a function which transforms them. It takes an object of type T, it produces an object of type R, and Bob's your uncle. You're off and running. So this looks a lot more like something you could plug in and have Spring Cloud Stream kind of accommodate by convention without having to have a lot of annotations that handhold it, right? That leak into your code that are very specific. It looks a lot more like natural Java code, as you will hopefully see. So with that, let's code. Does anyone recognize this guy? Maurice Moss, yeah, whoever called that out, thank you. The rest of you, whoever doesn't recognize this gentleman, there's a Britcom called The IT Crowd. It's a few years old now, but it should be on Netflix, right? I think. If not, find it. It's well worth your binge watching this weekend. There were only like 22 episodes. Awesome, this is one of the protagonists, Maurice Moss. So hopefully it won't go like this, we'll find out. All right, so let me switch back to this. And mirror displays, much nicer. Okay, blow that up. All right, yeah, so this is really where we need to be. Okay, so I love when Josh goes before me, because that way I don't have to show you what this is, right? Everyone knows what this is, right? I don't even have to do this. Start, spring.io. Start, spring.io. If your children are restless, I'm kidding, okay. So everybody knows what this is, so I can launch right in, that's good. We're gonna create three very simple microservices and we're gonna plug them all together with underlying messaging platforms. I have running already in containers, RabbitMQ and Kafka, right? And Zookeeper, but that's another topic. So we have everything running underneath, so I can run this all locally. We also, if we have time, we'll see. If we have time, I can also point to cloud instances as well. It all works very similarly, and it's super easy. But I'm going to go with pretty standard middle-of-the-road type of configuration here because, again, this is pretty simple, and I want to focus specifically on the evolution of the API, not on the window dressing. So I'm going to create a Java and Maven project, right? I'm going to use the current version of Spring Boot 2.2.1. I'm going to change this to the Hecklers because I can, and I'm going to create a source, an application that will implement a Spring Cloud Stream source, one that implements a processor, and one that implements a sink, right? I'm going to bring in some very simple dependencies like Spring Web, and then Cloud Stream, of course. Stream, Cloud Stream. There it is. Now, with Cloud Stream, it even tells you, look, oh, boy, that mic. It even tells you, look, you want to interact with a messaging platform, so if you want to do that, you have to include a binder in your project as well. kind of makes sense. It gives you a little bit of a hint there. Whoops, come on, there we go. So since we know we're going to need a binder such as RabbitMQ or Kafka, let's bring them in. I'm going to bring in RabbitMQ and Kafka, because why not, indecisive. And then I'm going to also add Lombok to my project, because I am a lazy developer. Unapologetically lazy, right? If those of you who use Kotlin already, forgive me, Kotlin actually completely obviates the need for Lombok. But if you're still using Java, you might want to poke around with Lombok. Maybe not in production, but certainly it streamlines things so I can show this rather nicely. So, all right, so I'm going to just save this to the desktop, and then just as a means of saving time, I'm going to go ahead and just create all three of these. So source, processor, come on, there we go, and my sink. Super nice. Okay, so I'm just going to open this up. So let's see, let's see, desktop, source. Open that in my favorite IDE, NetBeans. Ha, kidding. Okay, NetBeans fans, got it, noted. All right, so is this legible in the back? Can you read that? Should I blow it up? Okay, font. I can make this larger. Let's see, we'll go to our embiggenist, high contrast. That jumps, right? Okay, so let's open our application properties. We'll go to our app, and we'll write some code. Okay, so life advice, right? They always tell you to do what you love. I love coffee. Any coffee fans? Wow, tough room. Okay, we got a few, that's fine. Okay, so I thought it would be really cool to tie together these services that actually cover all the way from a coffee farm all the way to the coffee roaster and packager, and then finally to the barista, the coffee shop. And then it's in your cup, you know, so you can drink that fresh coffee. We ought to just pause right now and go get some, right? Yeah, maybe not. Okay, so I'm going to just create a class. We're going to call this our wholesale coffee, because that's what we're going to start with out at our grower. And I'm going to create a couple of fields like ID and name, very simple. I'm going to have Lombok make this a data class and create an all-args constructor. At data just says, hey, Lombok, create me my getter, setters, equals, hash code, and two-string methods. All-args constructor just says, Lombok, create me a constructor that has an argument, a parameter for each one of my member variables, which at this point I have two, right? ID and name. So it creates a constructor that has both those parameters. So super simple, right? Now, since this is a source, it's going to produce values and push them into the pipeline. We could do that manually. That sounds like a lot of work. Don't want to do that. So I'm going to create, again, I'm going to create a component, if I can type, and we're going to create a coffee generator. So we don't have to do that, right? That's the hard stuff, coffee generator. And I'm going to create a couple of things here. I want to create a list of string, type string, come on. There we go. Super nice. Okay, and we'll create coffee names. And let's see, we'll do an arrays as list. And I need some coffee names. Does anyone have a favorite coffee? What was that? Okay. Now, I didn't hear that, but I'm not sure I want to. Let's try someone else here. What was it? Can you spell that for me? This is really important, right? Because garbage in, garbage out. If you don't get good stuff, it's terrible. The rest of it just goes downhill. What? I came all the way out here for Nescafe? Oh my gosh. Dishonor. What's it? Kopi C. This is the like artificial Kopi Luwak, right? No. Oh, okay. So K-O-P-I-C? That is in like this? K-O-P-I-C? Wow, okay. All right. Well, okay, somebody out here called something out. What, again? You're not doing the Kopi Luwak thing, are you? So I get the idea that this is a problem. Copy O? Okay. So time is limited, but I really need to know, what is the joke here? Are these truly terrible coffees? No, okay, they're good coffees. I'm trusting you. I'm trusting you. Yes, you. All right. All right, I need a third coffee at least, or I'm going to have to like offer up something really terrible. Espresso, okay, well, we can do espresso. And then somebody over here called out something. What was that? Oh, no, come on. Come on. What is it? Croissant? C-O?
Hey, Mark, all these drinks are like local. They're like local coffee, so that's the joke.
Okay,
Yeah,
that's
local.
fine, that's fine. Local's good. Okay, one more time. K-O-S-O-N-G. Oh, okay. K-O-S-O-N-G. See, now you had me worried. There was a guy on our team years ago who would come and he would is anyone familiar with Folgers from the US? It's freeze-dried, instant, terrible stuff. Dirt. I think it's dirt. I really think it's not really coffee. So he would always come to my talks and he would wait for this part and he would yell out, Folgers. He had to go, all right? So I'm just making sure nobody's really setting me up here. Okay, so we have coffees. We have a list of coffee names, and I'm just going to create a bit of randomness here, an element of randomness, because random is fun, right? So let's see. For our generator, we want to generate wholesale coffees. We'll call this method cleverly enough generate. Return new wholesale coffee. We'll use UID just to create a random one in the string, and then we'll take our names. We'll get. We'll use our random to nextInt based on our name's length, right, our size. Boom, now we have a coffee generator. Now we don't even have to work on that. That's great. So at this point, we'll go to up here, and we've got a way to generate coffees, but we're not pushing them into our pipeline yet. So we need to fix that. So I'm going to just create a configuration class. I'm going to enable scheduling. Again, lazy. And I'm going to call this our coffee grower. Grower. And our coffee grower, we need to inject our coffee generator so we can use that. Now, we can use field injection, right? This is Spring, we could, but field injection's evil. Don't do that. And we could create our own constructor, right, to do constructor injection, and that's okay. But again, lazy. I'm going to use Lombok and have Lombok once again provide me an all-args constructor. Since we have one member variable here, it just does that nicely. So now I need to schedule something, and we'll schedule this at a fixed rate of 1 per second, and I'm going to create a bean. Now, if you're used to the typical Spring Cloud Stream way of doing things, you're like, hey, there should be a source and a send to and things like that. But again, we're going to keep this pretty simple, right? We're going to create a supplier of wholesale coffees, and we'll call this method send coffee. Sounds like a plea for help, right? And I need to correct that because it won't work with typos. Kidding. All right, so we're going to create a supplier, and let's see, we need to do a generator. We have a generator, right? We'll just generate that. That's it. It's so clean and elegant. Now, I am going to provide a few configuration settings here. I'm going to set my server port 0. That way, when I spin up multiple services on my laptop, they don't conflict, because with Spring Boot, when you say server port equals 0, it looks for an empty port, a random empty port, and it uses that. No conflicts. Life's good. And then I'm going to set my bindings. Now, in the old way of doing things, you had input and output channels, things like that, and it's clean and it's nice, but you're having to specify this stuff still. In this case, we basically pick up what we have here. We have a send coffee method, so we're going to do a send coffee, and this is an output channel because this is a source, right? So by default, we have an output channel, and we have an argument 0, because in the case of the new evolving API, you can have tuples coming in and tuples going out. You can really get crazy clever with your transformation applications or microservices. But in this case, we have one Gazinta and we have one Gazouta. Actually, we don't even have a Gazinta, right? Because this is our source. We're just pushing values into the pipeline. So we have an output channel. So send coffee is our output channel, out 0, and we're going to set the destination to a pipeline we're going to call processor. Now, if we look at our POM, we see that we have two binders, one for Kafka and one for Rabbit. If you only had one binder specified, Spring Boot's autoconfig would say, look, you want to talk to a messaging platform, you have a binder for Kafka, we'll use Kafka. But you have two. Spring Boot can't decide what you want to do, right? You have to give it a little more information than that. So we are just going to set the binder, we're going to specify that to Rabbit. Now, since I know at some point I'm going to be switching over to Kafka, I want to add a couple Kafka parameters as well, Kafka configuration settings, and that's fine. So Spring Cloud Stream, Kafka binder minimum partition count, I'm going to set this to 4. So when we start using Kafka, Spring Cloud Stream can initialize and create those partitions for us, minimum of 4. So that's pretty nice right out of the box. Okay, so there's our source. Let's go ahead and go back now. And we will create our processor rather quickly. Oh, 9.5 minutes. We've got this. No worries at all. Okay, so once again, we'll go to our application properties, application, no, not that one, application. There we go. Now, this is our processor. So we know that our source is sending wholesale coffees into the pipeline. We're going to need to grab those wholesale coffees and process them in some way. So we're going to start off with that. So at data, at all constructor, class, wholesale coffee, and string ID and name. Perfect, name, can't type, nice, okay. So we're getting wholesale coffees, but what are we going to do? We're going to process those into retail coffees going out the other end. So we're going to, again, use Lombok, all constructor, retail coffees, because at this point, the magic happens, right? So we, again, have things like an ID and a name, and that's perfectly fine. But when the raw coffee beans come in, what do we need to do? We need to clean them, we need to roast them, we need to do something maybe in between and then package and ship them out. So we know that going out, they will have a couple different states. We're going to offer them in 2 different packagings, if you will. So we know that the proper way of doing things is this, right? Whole bean coffee. Whole beans. Really, we should all be getting whole beans. I don't want to take up too much of my own time here, but if you're not drinking coffee that you grind and then place into your coffee brewer, you're doing it wrong. So think about it. The best way, as the gods intended, is to grind the beans and make the coffee. It's the freshest you possibly can have. But if you're traveling, if you don't have time, we should also be able to provide ground coffee for those poor folks who just need a quick hit, right? So we're going to do that against our better judgment. So we'll have a coffee state that we're going to provide as ground coffee as well. So now we need to do something to process this. So again, I'm going to create a configuration class. We'll call this our coffee roaster. And again, for a little bit of randomness, I'm going to insert a random here. So rnd equals new random, nice. And then we need to create a bean. Now this bean is a function, right? We want to implement a function which will take a wholesale coffee. Wow, typing went downhill fast. Wholesale coffee and produces a retail coffee, and we'll call this process it, right? And we will, let's see, we're taking in a wholesale coffee, and we need to do something with it. I'm going to just expand this just a little bit more so I can do some other stuff in here too. So we'll create a new retail coffee. We'll call this actually our coffee for short, and equals new retail coffee. We'll use our wholesale coffee's ID, and we'll use our wholesale coffee's name. And then with some randomness, we have 2 states, right? Whole beans and ground. So we'll use a random function to grab either a 0 or 1. If it's equal to 0, we'll say that we're producing a bag of whole bean coffee. If it's not 0, if it's 1, then we should produce a bag of ground coffee, and we'll pass that on. So that's pretty simple, right? And then we just go back to our configuration properties, Spring Cloud Stream bindings. And again, this is process it. We have an input channel, right? We only have one input, that's fine too. So our destination is pulling from a pipeline called processor. In this case, we want to specify a group too. Because if we specify a group and we spin up multiple instances of this service, then we are implementing the competing consumer pattern because they're in the same consumer group. If you don't do that, if you have multiple consumers that are not in the same group, they all get a copy of the same message, every message. And if you want a fan-out pattern, that's what that's called, that's great. That's how to do it. But if you're wanting to scale, you want them to compete. So if you have 1 or 2 or 10 or 20 or 100 different consumers, they take turns. And that allows you to scale out very nicely, right? Or scale back in when the bulk of the messages subside. We also want to, once again, specify our binder. In this case, once again, Rabbit. Now, this is our processor, so it has an input channel and an output channel. So we also have a process it out 0, and destination. In this case, we'll push this to a pipeline called sync. No need to specify a consumer group because this is a producer on the output channel, right? But we do still need to indicate whether we want this to be bound to Kafka or Rabbit, since we have both binders in our class path. So we'll say Rabbit here. And again, because we know we're going to be using Kafka later on, we'll just plug that in here with a minimum partition count of 4. And we should be off and running. So I'll go ahead and start that. And then let's go and create our sync. And then let the fun really begin. Oh, I'm missing something here. Hold on. Sync. And while that's coming up, we'll flip back over to our processor. Missing return value. Oh, I got ahead of myself. Okay, so now I want to do an rcoffee sout. And that just lets me see what it is. And then return rcoffee. Sweet. Let's try that again. Now, we'll go back over to our sync. And we'll open our application properties. And we'll go to our application code. And we'll write this. Now, our processor took what? It took wholesale coffees, transformed them, packaged them, and shipped them out as retail coffees. So our sync should only, what? It should only deal with retail coffees. It should only even receive those or care about those. So we're going to make this our retail coffee domain class, private final string, ID and name, and private final state, and then we have an enum, state, whole beans, and ground. Sweet. Okay. At this point, once again, we create a configuration class, and this is our coffee drinker. This is the payoff, folks, right? And we're going to create a bean, not a breen, and this will be a consumer. That's us. Okay, so we're going to consume our coffees. We'll call this drink it. And we can do this. We'll just take a coffee, and we'll do a system.out.println coffee, and that's fine, but of course, we can just make this a method reference, which is even cleaner, super nice. And then let's go here and do the same thing for our properties, Spring Cloud Stream bindings. In this case, we have drink it, and an input channel only, right? And destination is sync. Once again, the competing consumer pattern with our group. And then, actually, let's do this. And let's make this our binder, Rabbit. And since we're going to be using Kafka at some point, auto add partitions true, and minimum partition count of 4. That's fine. All right, let's start that up. Our processor is running nicely, as we expected it would be, because nothing ever goes wrong in live demos, ever. Okay, so there's our sync. So now we'll go back to our supplier, our source, rather, and we'll kick that off. Minute 39, perfect, look at that. And we have our coffees flowing through. So that's pretty nice, right? Now, since we only have 1 minute and 39 seconds to go, what I'm going to do is skip ahead a little bit. I'm going to skip the scaling, which again is super simple. Happy to talk about that later, but what happens if you want to switch these over? And actually, let's see, why not? Why not? What could possibly go wrong? All right, so I'm going to go up here. We're going to convert this to Kafka, and we'll restart this. This is our source. We'll go to our processor, and we'll go here, and this will be Kafka, and we'll pull in values from Kafka. We'll restart that, and then we'll go to our sync and change this to Kafka, and we'll restart that. So if you're a manager and you want to immediately switch all your underlying infrastructure, please don't. I guess that's the first thing. Please don't do that to your people. But if you have a manager like that, plan ahead, and it's not really that traumatic, right? So here we go. It was really just that simple. Now, I'm going to go back to my source and stop that just so I can show you. If we look here, indeed we see that it is set up and running on Kafka, so there's no funny business going on here. Yeah, so Kafka version, Kafka commit ID, and all that. So now, what happens if you need to use them both? Well, let's take our source and push things to Rabbit. And we'll leave our sink pulling from Kafka. But in the middle, we have our processors. So we should tell our processor to listen to Rabbit, listen to the exchanges and queues in Rabbit, and then push out to a Kafka topic, right? And that's all relatively simple to do, as you can see. You just tell Spring Cloud Stream and Spring Boot which binder to use, and off you're running. So yeah, there's our sync. Actually, I'm going to go back to the sync, and we're getting through our coffees just fine. So much more to tell, so much more to show, but just no time. I'm seeing 4 zeros, so I probably should be a good teammate here and stop this. So there, I'll stop this, and we'll go back, and we'll finish up the presentation. And then, like I said, I'm happy to stick around and chat and answer questions or just share information. So with that, here are some useful resources. If you want to see all this code and more, and actually I need to update with the newer evolved API. I think I'm still pointing at the old API, but I'll fix it here shortly. It's the repo drinking from the stream under my GitHub account. If you want to know more about Spring Cloud Stream, there's a Spring Cloud Stream project page. You can go to GitHub and check that out as well. From there, you can check out the API docs. You can check out all kinds of different examples there as well. You can reach me by email. These are my 2 email addresses that are the ones that I check the least infrequently. I don't stay on email much, but I do check them from time to time. And MKHeck on Twitter. If you have a question, comment, or feedback, Twitter is the best way to reach me. If you have something you don't want to share with the whole world, though, that's fine too. Direct message me. My DMs are open. And that way we can talk privately if you want. That's fine. If you're a Kotlin fan, yay! All this stuff is out there in Kotlin as well. So check out the repo at the bottom. And with that, thanks so much.